Hello, everyone. I'm Adam Gagol from Aleph Zero. Oh, do I have a pointer? Yeah. Thank you. And I'm going to talk about privacy and some trade-offs between privacy and anti-money laundering techniques, mostly in the technical way, semi-technical. So what I'm going to specifically talk about is how I try to explore some trade-offs between privacy, transparency, and do some commentary on compliance. Quickly introduce the ideas I know, how people approach this problem. I'm not going to provide the best solution to the problem, and I'm not going to pitch our projects too much because, well, I don't like talks where people pitch projects too much. So, to get things started, let's define a few topics. So it's not only in blockchain case, but in general we can divide anonymity into several categories. From pseudonymity, which is what usually happens on Bitcoin, where users have distinct pseudonyms or addresses and they can transact between each other. And then it's enough that we assign address to a user to be able to track a given user. It also gives some additional trackability that we're going to explore in a moment. There is anonymity, which is a stronger flavor of privacy. In anonymous system, what we know is only what happens, and there is no way of telling who is performing this action. So, for example, we can see that someone is sending one Ether to someone else, but there is no way to link this transfer to any other transfer that ever happened. And private system is a system where basically everything is concealed. So the only thing we know is that something happened because some data is landing on chain, but there is no way to tell what kind of data is it and what actions are performed. So first, maybe quick recap for how normal pseudonym transaction transfers work. So this is basically how Bitcoin works. So people have addresses. Addresses can transact with each other. And for example, this is actually Ether. So the mint address, let's say, is sending one Ether to the violet address every month. And then every month, violet address is sending 0.2 Ether to a pink address. So first of all, any observer can easily block this actions because this is the same address. So obviously, it's the same party. Then there may be some temporal relations between the transfers, like here, for example, if something happens every month. And then, even if some of these users wants to be anonymous, but others are not, for example, if Mint is a well-known employer with a well-known address, and the pink one is, for example, well-known hacker house, then it's pretty easy to tell who the violet one is. Well, he's the employee of this particular employer who is living in this particular hacker house. So even though, like, in principle, this system offers some anonymity. In practice, it can be very often broken. There are companies which are doing this professionally, and they claim usually that something like 80 to 90% of Bitcoin addresses can be actually linked to individuals. So there is an idea of stealth addresses on Ethereum. This is something that is pitched as a privacy improvement for Ethereum. What does it do, basically, is that each time I'm sending a transfer to someone, I'm generating a new address to this person. And I'm doing some cryptographic trick so this person will be able to actually receive the money. But it's going to work the same way as this person would generate a new address just for the purpose of me sending money to this person. So what can be tracked here? First of all, well, it's only for the receiving addresses. So if I'm the sender, chances are I'm actually sending money from the same address several times because usually I have more funds on this address than I want to spend in a single transaction. And the other thing is that there is this property of linkability. So if we have a situation from the slide before, we can link the first transfer. Two transfers in January are linkable because there is the same address which first received the funds and now transfers it further. So, for example, this is, for me personally, very, very hard when interacting with blockchain. Whenever I want to send funds to anyone, just to, I don't know, like a very small transfer, there's always this thought that, well, okay, so this person will be able to peek into my wallet after I do it. I mean, like, whenever I interact with anyone, this person will know my wallet from my address from which the transfer came, so we'll be able to tell state of my address. So of course, probably most of you are using multiple Ethereum addresses. This is of course not very user-friendly. And also, it doesn't actually offer cryptographic kind of protection. It's just a heuristic to make things a bit harder to track. So stealth addresses kind of work, offers some anonymity, although doesn't solve this problem of people looking into our account. And there are fully private transfers. So Zcash, Manta, Aleo, Liminal, which is our product, we all basically use very similar technology stack. And well, what's visible on chain here is basically just the aggregated number of how many transactions are happening. So there is no way to track anything, which is on a way nice, but it's also problematic, as that title of my presentation is about black hats. So how a black hat sees private transfer. So, well, black hats doesn't actually like Ethereum itself. I mean, whenever there is some hack, of course, like everywhere in the internet, we can read where these funds from the hack are actually deposited, because it's easy to track things on Ethereum. So, so usually story is that the hack is discovered, and then the address at which the stolen funds are is just public for everyone. So just mixing through Ethereum doesn't help at all here. It's very easy to track these funds, so it's very easy to put red flags on all the addresses that have been receiving the stolen funds. Ethereum stealth addresses, basically nothing changes here. I mean, as I said before, there is full linkability, so it's easy to track across the transfers where the funds are being deposited. So, well, stealth addresses give some flavor of anonymity, not for black hats though. And there are private transfers, which unfortunately are a heaven for black hats, because whenever the funds are getting there, like the trace is absolutely lost. So, so the question now is, can we make it somehow better? Can we make it so that our normal transfer recipient will not be able to pick into our wallet, but also in a way that black hats will not be able to launder arbitrary amounts of money in the system? So it's a hard problem, and there is no like clear solution for it. There are several approaches, though. The first one is called anonymity revokers. This name actually comes from academic paper. I'm not even sure whether the deployment will be called the same. So the idea here is that there is a specific set of nodes which are holding threshold encryption of everything that happens in the system. So basically, we can imagine the system which works exactly like Zcash, so fully private transfer system. But there is this special committee. So then the hacker story would look like this. Well, hacker stolen funds are deposited to the privacy system. Then, well, a hack is identified. Let's say we're on Ethereum. Hack is identified, and the funds and this particular deposit to the privacy system is identified as well. So, like, basically everyone knows that the funds came from this address. So then, some authorities come to the anonymity revokers and say, well, there was this hack, and they request to reveal everything that is related to this particular deposit. And then anonymity revokers, as they hold encryption of everything that ever happens in the system, they just reveal everything step by step by step. And, well, it's kind of unclear what happens then. I mean, freezing funds is usually problematic, but revealing is enough, actually. I mean, like, the hacker attempted to mix the funds and failed. That's good enough when it comes to designing safe privacy systems. So what's the problem here? So the core problem is that there is no way of preventing anonymity revokers to just secretly reveal everything. I mean, they don't need to do any chain interaction to reveal things. They just have encrypted data, so they could just collaborate and decrypt everything. So the problem here is that the data are not under user's control. But, well, the benefit is that this solution is pretty simple when it comes to technical details. So, yeah, it has some benefits, but it comes with a great cost that the privacy is compromised to some extent. And the second class, let's say, I'll call it here proof of innocence because of recent Tornado Cache-related protocol. So what proof of innocence does is, well, let's come back to the hacker story. So here it would look like this. Hacker deposits funds to a privacy system. And the hack is, of course, identified and the address becomes public. And then, well, authorities, there is no anonymity revokers. No one to ask to reveal anything. So what the authorities can do, they can just say that, well, so this address is problematic. Whenever anyone interacted with it, well, it's gonna be problematic. So there is just, they are creating this kind of list of problematic addresses. And then, whenever some address is accepted as the problematic, this is of course unclear what does it mean and who actually accepts these addresses, but let's leave this part for a while. It becomes possible for users to generate proofs that the funds they are withdrawing from the system never interacted with this particular address. So as a user of a system, I can provide proofs of my innocence. I control entirety of my data. So no one can peek into my transactions, but I myself can prove that my funds are not coming from the blacklisted address. So advantages are clear. It's full privacy, uncompromised. There is no one who could actually peek into my history, and well, everything under user control. Problems, like too much to fit in such a small window. So I'll make another slide with problems. So first problem, like partially technical, partially legal, who controls the list of problematic addresses? It's of course a very problematic matter. So probably some kind of DAO or some kind of decentralized governance, but it's yet unclear. I don't think anything like this was ever implemented. Then what happens if stolen funds mix with the regular users' funds inside of the system? So there is no clear answer for this question, but fortunately, it's not a problem which is related to blockchain itself. I mean, the same problem basically happens in normal finance. If someone steals money and then mixes this money with money of regular users, then it's just the same problem as here. So I'll consider it pretty problematic, but not specific to this particular use case. How to keep trace of private funds forever? I'm not gonna dig too deep into that, but generally these privacy protocols become more and more complicated the more and more we're trying to keep this track. So summing up, the paths here are two: anonymity revokers, which are making a bit worse trade-off for users. So they kind of risk that the privacy will be compromised, but the benefit is that they offer pretty straightforward system and can be probably quicker implemented, and proof of innocence-based systems, which doesn't compromise privacy, but may be limited when it comes to the technical capabilities, like for example throughput or how long the track can be actually remembered. We're exploring more the latter part, the proof of innocence part, as we want to keep all the data under user control. And probably you'll see something about it this year. The way forward, well, we need to find a system that replicates the privacy we have in real life, because right now we kind of accepted that blockchains are less private than normal finances, but well, it should not be the case. The second is that we need to find a system that reasonably prevents black hats from using private transfers for mixing funds. And well, it's not clear which solution is the best. I truly believe that the second path is better. Thank you.